planet. Now the next small planetary body I want to talk about is asteroids. They're small, generally rocky, bodies that orbit the Sun. And most, or thousands of them, lie in what we call the asteroid belt. It's a region between the orbits of Mars and Jupiter. The first asteroid, Ceres, of this asteroid belt swarm was discovered in 1801 as a result of something called the missing planet. Bode was looking at ratios of where all the planets were. He predicted there would be another planet between Mars and Jupiter, and looking for it we saw the asteroid. Now the combined mass of all the asteroids is probably less than 1/1000th of the mass of the Earth. This picture shows the asteroid belt. Now not all asteroids lie in the same place. Here we have the orbit of Mars and the orbit of Earth. Notice some asteroids are actually inside and they'll actually cross paths with Earth. Those are the ones we're worried about. We'll talk about that later. This object region between Mars and Jupiter is called the asteroid belt. And there's some asteroid belts called Trojan asteroids that are about in Jupiter's orbit that lead and lag Jupiter by actually exactly 30 degrees from the center. And we'll talk about those more later. Now, the region between Mars and Jupiter isn't so thick with asteroids we can't really see out. Each of these dots represents an object that on the scale of this picture would be completely invisible, but they needed to be a large enough dot in order to be able to see them graphically. Now asteroids are small, so their sizes are best determined from infrared measurements. Bigger bodies emit more IR than smaller ones at the same temperature. Asteroids range in size from 1,000 kilometers across, Ceres, down to kilometer-sized objects, or some even smaller. Because asteroids are small, they have low gravity and no atmosphere. Also, they can have irregular shapes, since weak gravity is not good at pulling planets into round shapes. So most asteroids are irregularly shaped, as determined from spacecraft images and from brightness fluctuations seen through telescopes. Reflection spectra show that asteroids belong to three main compositional groups: carbonaceous bodies, silicate bodies, and metallic iron-nickel bodies. Inner belt asteroids tend to be silicate-rich, and outer belt tend to be carbon-rich. And some asteroids are loose lumps of material just held together by gravity. We can see this object. Might be a larger object back here, but there's lots of small chunks that have come together over time and are stuck due to the small gravity between them. So from their composition, size, and location, asteroids support the solar nebula hypothesis and are thought to be fragments of planetesimals. Now for this connection to be established, differentiation needed to occur in the large asteroids. Fragmentation of the early large asteroids, planetesimals, through collisions created by stony and iron asteroids we see today. The asteroid belt is the result of Jupiter disturbing the accretion process in that zone and preventing a planet from forming in that zone. So what do I mean by they must be differentiated? Here's two pictures of a non-differentiated asteroid and a differentiated one. In the non-differentiated, we have a mixture of iron, nickel, and rock all throughout. Differentiated one, the radioactive heating melts the material so the iron and nickel sinks to the core and the rock and other materials left on the outside. Now, if I have a differentiated asteroid and it's broken up by a collision, we should get some fragments that are completely iron and nickel and some fragments that are rock, which if we look at things that have fallen to the Earth out there, this is exactly what we see. Now, the NEAR mission, or the Near-Earth Asteroid Rendezvous, put a spacecraft in orbit around the asteroid Eros, and actually landed on it in 2001, and sent back data for several days, but the camera did not survive the landing. This was basically because there was no landing gear on it. This spacecraft was sent to Eros and went into orbit around it to take pictures and take some data. After a while, when they had done all the scientific experimentation that they could, the engineers at NASA said, well, what can we do now? So they decided, well, let's try to land it. There's no landing gear. but that didn't have enough fuel to attempt to slow down and to land. And these are pictures of it as it's getting closer. And we see craters as micrometeorites struck the surface. It's pitted with large and small craters all over the surface. And we see a picture here of the surface taken by the camera, which was looking straight down at 250 meters. And the last photo taken, the picture was taken, and as it was transmitted, it hit and knocked the camera out and damaged it slightly, so that the spacecraft sent this last row of pixels over and over and over again. There weren't these straight striations on the planet. As it was transmitting here, it transmitted the same thing over and over and over. Since it was broken, it didn't have landing gear when it landed. Now, the Apollo asteroids are asteroids that actually are carried into the Solar System and cross the Earth's orbit. There are about 700 of these, and they represent a collision probability with Earth once every 10,000 years. These could be dead comets that are shifted into their orbits by Jupiter. They're devoid of surface ice because they've come to the sun too much and melted off all the ice. These are the ones I said that we're worried about.